Luke is proud to be part of the community of stormwater education and training professionals that have effectively certified thousands of individuals. Luke is a level 1 and level 2 trainer, and we definitely thank you for your time, and I look forward to hearing from you. Thanks, Luke. Just unmute.
Okay, can you hear me now? Okay. Well, thanks, Ben, for the introduction. And it's really, I'm honored to be able to be here. And, as I was going through this presentation, a lot of things go through my mind as far as there's a lot of people out there in the audience, people that have a lot of experience with installing skimmers, people that have designed many of them, people that have tried to maintain them. But, even more fundamental than that, I wanted to kind of start off by talking about certain things related to our water quality and things that we have to consider as we're making decisions on how to or whether or not to install the best management practice or whatever. I just left Augusta. I was in Augusta and I drove by, I don't know, scores of construction sites, and many of them, from my view, the sediment was fully exposed, construction exits were missing, and so I see that, and then I'm like, well, now we're going to talk about skimmers, it kind of seems like that doesn't make sense, but it does make sense given the country that we live in, the expectations we have of ourselves to keep our creeks and our streams clear like this. Is it really fair to expect that, we'll have creeks like that? When I caught that trout in North Georgia it was last year. And now there's new construction going on up there in that same watershed. And it makes me wonder whether or not I'm going to be able to catch that trout in 5 years. Or am I going to be looking like this creek, this is Swanee Creek in Gwinnett County? Is that what we're going to expect coming from construction sites? I don't think that's necessarily what we have to expect. So that kind of begs the question then, what kind of control do we actually have over our development? Point source or non-point source. This obviously is a non-point source. Non-point sources are not required to file a notice of intent under the Clean Water Act if they have a land disturbance of 1 acre or greater when it's agricultural like this. But point sources absolutely do have that requirement. And yet we're seeing things like this going on where discharges are leaving the site. This is just one of countless that I've videoed over the years. And yet that's going down to a creek that's going to be putting that sediment into the Chattahoochee River that takes it down to the next dam, which is Morgan Falls Dam. That dam is, it's building up and moving up towards the dam as we speak. We're getting a rain event right now. So what is it that causes a contractor to, and we have to ask ourselves this as design professionals as well, is what causes a contractor to take a 35-acre site, the sheet erosion occur and the volume of water into a temporary down drain and shove it down to a storm drain? Illegally, obviously. This is a point source of discharge. What is it that causes a contractor to just take the water and instead of putting it into a sediment basin with an outlet that's going to be protected with a retrofit, what causes them just to put a pipe in that's going to take it directly through the buffer and into the creek? I videoed this last year. You may have seen it if you've got my newsletters. This video was taken from a perspective of just trying to understand where this sediment was coming from. This was a fairly nominal event right here, but this had been going on for months. And finally, because a neighbor's complaining and whatnot, I thought, I'll just kind of chase it down and see if I can find where the sediment's coming from. So this occurred in March, and then we have another shot here that occurred in February. So as the drone shot, I'm going to kind of skip along here, kind of accelerate this a little bit. But you can see this sediment came from a single 2-acre site. That's it. The stormwater that was running near this project was relatively clear. This had been going on for months. And what happened was the permittee was not really a permittee. He had gone down to the county. They didn't even issue a land disturbing activity permit, when in fact they should have required a notice of intent to be filed. And of course, that would have required a design professional to be put in place, where even a sediment trap or two would have really helped to resolve that issue. Of course, they all have to be maintained, and we'll talk about all that. But as you look at how even the best management practices were installed here, Mulching was at one time over this area, and then of course it sheeted off. It was poorly anchored or not anchored at all. The sheet erosion, obviously, a lot of the sediment's already gone from here, but I kind of highlight that here. But then as that water comes off to the edge of the site, you notice the rills developing, and then the silt fence is channeling the water. And the creek downstream essentially just had no hope, of trying to keep it self-clean with this discharge. And of course, that all went into Lake Lanier. So what is it that causes a contractor to do this? These are questions we think we know the answers to, but there's a lot of things that a superintendent is responsible for. And so, part of their responsibility also is to manage these sites as stormwater treatment systems, and lo and behold, they really don't know that. So in this particular case, we have a surface skimmer that's installed in such a way that it couldn't possibly be maintained. If it's even operational at this point, it's doubtful. And of course, look at the erosion around it inside of the basin. It's just a rough way to look at trying to manage a skimmer. So when you take a look at a shot like this of this lake, you can notice the lake in the background is real clear, but here it's full of sediment. And there's really no excuse in the Clean Water Act for this to have occurred. And as I get to talking more about this, we have to look at construction sites kind of from an idealistic perspective. The Clean Water Act does not sympathize with, your construction schedule didn't work quite right this way, or if it's an industrial facility, there was an accidental discharge, we didn't change the filters out because the guy didn't show up for work last week, he was sick. The Clean Water Act is not sympathetic to that. And it really can't be, because it's people downstream that are the ones that suffer the consequences of this. A stormwater treatment system, meaning that the notice of intent was filed for these projects, or should have been, meaning that the water hitting these jobs here should have been controlled in such a manner as to prevent that amount of sediment load from leaving them. So, of course, we're seeing a severe degradation of water quality there. And, of course, the people that live up in the upper reaches of these bays, of course, their docks are sitting on sediment right now. So those are two point sources of pollution, where non-point sources like farming, agriculture, largely responsible for trash in a lot of our rivers and our creeks and our lakes in Georgia, for sure. But in metropolitan areas, I really wonder if sediment from non-point sources is our nation's number one problem. I really think in urbanized areas, from what I've seen, and I think you guys would agree, that sediment from point sources is our number one pollutant problem in urbanized areas in states like Georgia, where we get so much rain. And that's really a shame. It really shouldn't be like that. But it takes training, it takes enforcement, it takes great designs, thoughtful designs that can be implemented in such a way to do more than just meet checklist items that are going to consider the fact that 27,154 gallons of water are going to hit that construction site on 1 acre. And these are designed for 25-year events. We're talking about 6.7 inches of rain times, that amount of water. That's an awful lot of water. So what can we do that's going to, address that issue? And so what I found is that in the Clean Water Act, there is a program referred to as the pre-treatment approach to managing industrial discharges. And I worked on industrial facilities in that program for many, many years. And so it naturally just came to me when I first started this program we need to start looking at things as, differently than we do right now with construction sites. So let's go back to the guidelines and start all the way from the federal government. I'll never forget, I was part of the meeting when we walked in the door of the stakeholders meeting for the general permit, and the Mpdes said, surface skimmers are here. What? And I said, what are they? And so here they are. Now they're written into our permits, and they're a federal requirement everywhere now in this country, unless they've been written specifically out for some unusual reason, which in the West, of course, they don't get that much rain there. But the federal law subpart B, construction and development effluent guidelines, come out of 40 CFR part 450F, paragraph F. And what Georgia did is we adopted those guidelines and we put those into our general permit as well verbatim. So that text in orange says, when discharging from sediment basins and impoundments, permittees are required to utilize outlet structures that would draw water from the surface unless infeasible. And the commission goes on to say, okay, well, if it's infeasible, it's not technologically or economically achievable, kind of streamline that a little bit. But they go on to say that if outlet structures that withdraw water from the surface are not feasible, a written justification explaining this decision must be included in the plan. Outlet structures that withdraw water from the surface are temporary BMPs and must be removed, as well as everything else. You know, silt fences, and we talk about that in our courses, but they're absolutely temporary and they should never be in place. Just right down the road here, there's a pond that's got a surface skimmer in it. It's a Marley skimmer. They're now mowing the grass that's growing on top of the retrofit stone that the skimmer is now inserted into. Why is the city allowing that to happen? You know, what's going on? So we have to kind of talk briefly about laws versus guideline. You may have seen that, you know, the EPA issued these guidelines in federal law. And when you look at definitions, you really have to understand the difference between law, regulations, and guidelines, and how states adopt guidelines can become law. By definition, following a guideline is never mandatory unless the state adopts guidelines that are issued by the federal government and requires them to be law. Guidelines are not binding and are not enforceable by law. Guidelines may be issued by an organization to make the actions of its employees or divisions more predictable and presumably of higher quality. Now, I think surface water skimmers are an important thing to be properly designed, installed, and maintained on construction sites, given the amount of rain that Georgia gets. You know, 55 to 75 inches of rain a year. We have thousands and thousands of creeks and streams. I mean, when I moved here from Colorado, Utah, I had no idea, you know, what streams and creeks were until I moved here. And we're kind of born, and many people are born in this state in the Southeast. And as a result, we kind of take for granted the importance of having our streams and our creeks in good shape. We'll talk a little bit more about that later. But let's get into the definition. You know, a floating surface skimmer, by definition, coming right out of the Green Book, is a floating surface skimmer is a buoyant device that releases drains water from the surface of sediment ponds, traps, or basins at a controlled rate. It skims or dewaters from the water surface where sediment concentrations are at a minimum in the water column instead of draining from the bottom where sediment concentrations are the highest. Now, when you take a look at the general permit, by definition, this really isn't enough. We can see coming out of the Green Book, the definition, the purpose, the conditions that skimmers are to work under, the design criteria. But in our general permit, we have a requirement for discharging to certain discharge limits. Now, this is not usual, business as usual. For you guys that come in from out of state or that have worked in other states, most states do not have discharge limits associated with construction sites. And of course, you know, the federal government tried to require that a few years ago and they lost. But Georgia does have them, and they're kind of not really considered all that important because of how we essentially manage construction sites in a way that does not conform to managing them as stormwater treatment systems. It's really a difference in mindset that has to take place. In the GAR 1 permit, I wanted to point out here that there are requirements for discharging to a certain limit. And I wanted to read just the first paragraph here, but the second one, basically, the first paragraph addresses discharging into a stream that's a trout stream or a warm water stream and measuring turbidity upstream and downstream of those discharges. The secondary highlighted area there is the same basic verbiage, but addresses sampling from the actual outfall. So what I wanted to point out is kind of in the second paragraph. It says, when the permittee has elected the sample outfalls, the discharge of stormwater runoff from disturbed areas where BMPs have not been properly designed, installed, and maintained shall constitute a separate violation. For each day on which such conditions result in the turbidity of the discharge exceeding the value selected from Appendix B, And that's essentially the same again as I had mentioned about the 25 and 10 NTU discharges for modern trout streams. I wanted to throw this up there. This is a memorandum of agreement, or a memorandum of, not a memorandum of agreement, but a memorandum that came out of the EPD back in 2009. And they address certain things, and it's worth a read. I've got it posted on my website under the links. If you go to mpdstraining.com, you can see it. But I wanted to point out some things here that say, therefore, a permittee who has designed, installed, and maintained BMPs in accordance with an approved plan, but who continues to discharge stormwater which exceeds the turbidity requirements of the permit and the ENS Act is not in violation of the permit. However, the permittee must comply with the requirements of Part 4 regarding inspection, plan revisions, sampling to address the failure to meet those standards. Where am I going with all of this? I put out several times in my newsletters and stuff about, and I've gotten comments back from very well-seasoned professionals in the stormwater business that skimmers are not intended to discharge to a turbidity standard. And I would agree with that in every state that does not have a discharge limit. That said, as we start to get into the design, installation, and maintenance of skimmer devices, we have to consider in those installations the ability they have to discharge to a discharge limit. That can only take place when you've got certain conditions happening and often would include flocculation. Now in the industrial, Mpdes industrial world, that's absolutely a requirement. As you'll find out as we start talking more about the pre-treatment program here. So here we have a skimmer that's not quite skimming from the surface. And here we have just a highlight that comes out of the green book that says floating surface skimmers that sink or completely suspend under the water surface are not acceptable. Obviously, this particular skimmer also, so I try to scroll up here, was inserted through a retrofit. There are contractors out there doing this now, and many municipalities are looking at it like, wow, that looks pretty sharp. As a matter of fact, a lot of our BMPs people look at when it's dry and fail to look at them like what's going to happen when they get wet. And so anyway, but where did the concept of pre-treatment come from? It came from the Clean Water Act. And what happened with the Clean Water Act when it was amended in '72 to include Npdes permits, it had gone on for 25 years and put in water quality standards that nobody wanted to comply with, and there wasn't any requirements to do so. So finally in '72, they amended it. A lot of language went into it, and the Mpdes permit program was born. Its goals, which still apply today, are very fundamental to America's water quality. I mean, we can go all the way into bass fishing tournaments. You can go into fly fishing that we all love to do. Many of us love to do. And if we fail to comply with the Clean Water Act and take it seriously, understanding that sediment is the #1 pollutant for fish, we're talking about a chronic pollutant that can bury eggs and affect fish gills and breathing and that kind of stuff in the water, then we've got a problem. So the #1 goal is to restore and maintain the chemical, physical, and biological integrity of our nation's waters. And that was true then, it's true today. And then, of course, we established the Mpdes program, meaning the National Pollutant Discharge Elimination System program, that is there to try to, or not try, but to establish standards, whether they're effluent discharge limits, water quality standards, or administrative structural and non-structural controls that we actually have to put in place. And on construction sites, for the most part, that's what we use. And of course, construction sites in Georgia do have an effluent limit. Clean Water Act focused on 2 point sources in the very beginning. And they were out of control. I mean, talk to anybody in Georgia that remembers the Chattahoochee River was so unfishable, you couldn't even hardly tolerate the smell of it because of all the sewage going into it. And industrial waste were also very much getting into the program of polluting our rivers and our creeks. And we've probably all heard of the Cuyahoga River that lit up, about 15 times starting in 1868, where there were no discharge limits and everybody was doing what they wanted to do, even though they knew better. people still polluted the water. It took enforcement of regulatory laws that really made the difference. So anyway, in 1977, because industries were told to disconnect from the creeks that they were discharging to and connect to a wastewater treatment plant, they realized real quickly, if they take in all that toxic discharge, that's going to kill the wastewater treatment plant. So they passed an amendment to the Clean Water Act in 77 that is intended to prevent the introduction of pollutants into a publicly owned treatment work that will interfere with its operation, including discharges that inhibit or disrupt the process or operations of that POTW. So where does that take us? You know, for years, as I mentioned earlier, I installed pre-treatment systems in industrial facilities that were associated with the oil field. People would, you know, many companies, there's one particular company I worked for, they rented drill stem and auger flights and drill heads and blowout preventers and all of that. So when they got done renting them, when those oil holes were decommissioned, they'd bring that equipment back into the wash bay and they'd pressure wash it. Well, at the time I was working back then, they had zinc and copper and all the pipe lubricants that they were using. The pressure washer then would discharge that water with the sediment onto the floor of the wash bay. And of course, there's a trench drain there. That trench drain, you can see the arrow, is capturing the sediment. And it's also capturing the oil that's not going to settle there. You notice where they first start to capture the sediment, to the point of where it's starting. So you try to capture the sediment loads, the pollutant load, as close to the source as possible. So remember that as we start talking about construction sites. That's definitely the goal. What can we do that's going to minimize that load so that when it goes down to the collection pit, in that collection pit, of course, you can see the brown and the blue water there has various stages to it. And that is still part of the passive treatment system. So we're using gravity, we're putting things in place that are going to create a higher residence time of that water in the collection pit. You can see a three-stage, three-weir system there that finally will take that water and take it down over to the active treatment system. Now that active treatment system cannot handle the water prior to it being passively treated. It's impossible. We had the hardest time getting people to maintain these systems. We'd try to sell them the contract to maintain them. They wouldn't do it. They would want to do it themselves. Does that sound kind of familiar to construction sites? It's a human nature thing. So anyway, active treatment systems then flocculate, they filter, they use charcoal filtration to actually kill bacteria. And then from that point, they would discharge it to a wastewater treatment plant. And then that would put the final scrub on it that would take it down to the state water or water of the US. Now, if you take a look at an industrial pollutant facility, pre-treatment facility, we're talking passive treatment in the collection pit. Collection pits are passive settling tanks built to remove the bulk load of particles from liquid or active treatment clarification. What does that resemble on a construction site? That resembles a sediment basin. That resembles a sediment trap. That resembles a collection area where the water has already got to be pre-treated. The sediment's got to be a large part of it must be taken out if this thing's going to function properly. And it certainly has to be maintained. When you're talking about the difference of a construction site and an industrial facility, you're talking about a massive difference in pollutant load. The entire floor of a construction site, if it's actually graded, if it's actually exposed and graded, is the pollutant of concern. And so it becomes incumbent upon the operator of these systems to prevent the erosion of that pollutant from entering the collection pit so quickly, or it simply overwhelms it. From that point on, of course, this is going to be taking it to an active treatment system, and construction sites don't have active treatment systems. Some do. But later on, stormwater was discovered to affect the chemical, physical, and biological integrity of our waterways. We have a little solid waste there, but now we have a huge pollutant load coming from a county road project upstream. So as time went on, after the Clean Water Act was amended to include requirements, very strict requirements for effluent discharges from wastewater treatment plants and industrial facilities, the EPA decided to study the effects of stormwater, since we realized that the chemical, physical, biological integrity of our nation's waters was not happening. We weren't doing it. So they studied 2,300 storms in 28 major areas around metropolitan areas across the nation, with the overall goal of discovering whether or not stormwater was adding pollutants to a significant portion to our watersheds. And it absolutely was. It even goes on to say after the red line here that a rational basis for determining whether or not urban runoff was causing water quality problems was really, that was the intended goal. And then to develop water quality management plans consistent with local needs that would lead to implementation of least cost solutions. What happened early on with the Clean Water Act is they decided that it was just not reasonable with stormwater to require effluent discharge limits. And many states in the very beginning, as they're trying to get their arms around all these new requirements, some required water sampling, others didn't. And since then, some have because of active environmental groups and things like that. But for the most part over the country, we really don't require discharge limits. But we do require that best management practices are properly designed, installed, and maintained, and that there's proof that that has taken place. That's really what is taking the place of sampling water outside of Georgia. Now, those are still integrally critical in Georgia, but not the only thing. We still have to discharge at a certain limit if we're going to meet our permit requirement. So what happens with construction sites and post-construction stormwater is that we're affecting the biological integrity of our waters when we take down the ground cover. Now in the West, where you have so much desert, not quite so much an issue as it is here. The aquatic habitat have evolved to be pretty intolerant, and talking about in trout stream areas, of sediment loads. And so here we actually have a large number of discharge points going directly into this lake. And just consider that to be the river that eventually does go down to a dammed lake in Georgia. We have no natural lakes. So that's a problem. Sediment is definitely a major pollutant there for those. And so it's a point source, and how Georgia manages those is to look at this construction site as a point source of pollution, meaning that there's only one legal discharge point on it. The operator managing this is where Georgia goes above and beyond with its certification requirements. Not just inspectors are required to have a blue card, but the people with a financial decision-making capability of calling in an erosion control contractor have those responsibilities to have a blue card. Then people that do site inspections obviously do too. And then the subcontractors, they came out a few years after the initial certification program, and that really says that, okay, subs, you don't need to know about all this Mpdes stuff. You don't need to be doing water sampling and site inspections. You just need to be aware of what the damage is that you're going to be causing to water quality if your activities strip a buffer, or if you don't properly install your BMPs properly for your contractor. So one person per crew has to have a white card. Then the red cards come along. They take the same quartz modules as the blue cards, but they get a little extra because they're regulatory inspectors. Where the blue cards are compliance inspectors, red cards are regulatory inspectors. Most of you guys know this, but there still is a lot of misinformation out there. So anyway, this would be somebody working for a county or a city or the Georgia Environmental Protection Division that is doing enforcement and making sure the site inspections are taking place, the water sampling is taking place, that the reportable violations are being reported, those types of things. And then you have, actually fundamental to all of this is the design and the checklist requirements that Georgia has, which are pretty amazing compared to most other states. So here in Georgia, we allow not just professional engineers and CPAS certified professionals in erosion and sediment control to design plans. We also allow those low-life geologists like me and landscape architects, land surveyors, and foresters to actually design plans. And then, of course, plans many times go into plan reviewers. They take the same class. That course takes the same stuff as a level 1A card certified person gets, but they get more in terms of just stormwater management, post-construction stormwater management issues. Of course, green infrastructure now is an MS4 requirement, so we learn a little bit about that. And of course, the checklists that we go into, and how to use the BMPs and add BMPs that we want to use on our sites. So at this point, we're going to start going through the pre-treatment program for construction sites. And of course, we all know that the effluent leaving this site now does not go down to a POTW. It goes directly to the river. So how are we going to pre-treat the water on this construction site in such a manner as understanding it's its last point of discharge? That sediment basin is really to be looked at kind of like a POTW. That's its last treatment point of discharge. What can we do that's going to pre-treat that water to a point where a skimmer could actually work, and let alone that, or maybe even just a retrofit, something that will actually be responsible for discharging water at an acceptable discharge limit. So here we have our challenges on construction sites. We have the increased runoff volume we've got to contend with that industrial facilities don't have to deal with. We have that increased runoff velocity, and we have that increased pollutant load that goes with it. Now, the pollutant load is what people get in trouble for. But these two troublemakers up here in front are the ones that really cause it to be such an issue. So in our designs, we've got to address it. If we don't address it properly in our designs, then people that are installing them in the fields are inadequate. And then they're having to come back later on and put BMPs in that'll actually work. And in this case, you can see here where just a huge load actually went and discharged directly into the lake there in the background. So volume, velocity, and pollutant load are the challenges. So what do we need to do? Okay, as a design pro and even as a superintendent or a site inspector, we actually need to understand the conditions of the soil. Is it a saprolitic type soil and eroded bedrock that's really, really grainy, kind of sandy, allows for water storage to some, to some effect? Is it going to be real erodible like sand on a slope, or is it going to be finer silts and clays that are not quite as erodible as a sandy soil? And of course, understanding the different types of erosion here, we have to understand that sheet erosion is the #1 source of most of the water that picks up that sediment load. That's our challenge really on a graded construction site. So as we start to get into the need for, managing stormwater on a construction site, we have to address sheet erosion. And that takes proactive approach of stabilizing soils. Here we have an example of just a graded area, small little lot in Beaufort, that's discharging a phenomenal amount of sediment off-site, going right straight down to a storm drain. So what we have to look at on an Mpdes site is, first of all, looking at this collection pit in such a way that's going to prevent the sediment from getting into it, and then what's going on in the collection pit. So erosion prevention first has to be considered, and then sediment control upstream of the collection pit. Then in the collection pit, like on an industrial facility, it's concrete. It's got weirs in it. I mean, it's not going to erode. But on a construction site, we have to properly stabilize our slopes. We have to properly stabilize the outlets that are discharging water inside of the sediment basin. And then as it leaves, we have to consider the water being discharged from these concentrated flow areas. So we have to prevent the erosion inside of the basin, as well as control or expedite sediment deposition as quickly as possible. And in this case, of course, they didn't even have an outlet that was adequate here. So before the collection pit, we need to prevent erosion. What's the very first way of doing that? If I had time to ask questions, the very best way would be to leave all the trees up. But that's not going to work on a construction site. So the next best thing...
Stabilization.
There you go. Okay,
Thank you.
Stabilizing it. So how do you best stabilize? Well, first of all, if we properly phase our projects, and this is where it comes into the community of setting budgets for the construction sites. Communities that are proactive with requiring the installation of perimeter controls first before they take down the trees, people go into those municipalities ready with a design and a budget to handle that, because they know there's going to be enforcement. But for local authorities that don't enforce this kind of thing, it's going to take a burn-in if you decide to change your way of enforcement. I mean, look at this. They went in, they took down all the trees, but they're not going to be grading here for another 3 or 4 months. There's no reason to start grading this right now, other than to, be considerate of remobilization costs and things like that. To a certain point, construction sites or stormwater treatment systems need to be sympathetic to construction sites, but we've got to be a little more proactive than what we're being right now. I think you might all agree. Of course, soil stabilization, here's a great example of that. But even as this gentleman's blowing a lot of mulch out there, there was no effort to anchor that mulch. I've seen more damage from down drains being plugged with mulch, mulch sheeting off and virtually being just useless with a minor rain event. Why even do it is my question. Why even pretend when it looks dry and it stays there? That's not its point. It needs to work when it's there. It needs to be anchored, and that grass needs to be anchored. Something I think is an underutilized best management practice that Georgia authorizes polyacrylamide, anionic polyacrylamide. And this is just from a Florida Stormwater Conference years ago, but it shows you the effect of basically spraying a polymer, whether it's emulsified or a powder polymer. Here they've got a fine jute membrane over it to kind of hold the soils in place, but basically kind of put a clear plastic film over this. Is just sheeting off the water, where the other side is, of course, going to create all kinds of damage to the treatment system itself and probably leave the site. So in the collection pit now, we've got to address the collection pit itself. Now, in this particular case, you can see the basin parameters are in good shape. The outlets coming in to the basin have not been maintained. And we have a nice little collection area there, a forebay that's not been maintained. And so sediment's building up and is starting to find its way around the edge near that retaining wall, that gabion wall. So we need to maintain our basins. We just need to maintain all of our BMPs. That the discharge management devices, the emergency spillway, the surface skimmer and level spreaders, all those need to be considered here. Managing sediment deposition, the sooner the better, is really important. And so, of course, we talked about preventing erosion, the sooner the better, grassing, mulching, making sure it works. And then as it comes and encounters structural measures, we need to do a really good job at trying to expedite that sediment deposition. And then, of course, that's going to take a lot of maintenance to do that. So here we have a great stabilized channel. We have rock riprap taking it down to a storm drain that's actually going to take it down to the sediment basin there. Here we have an inlet sediment trap that's doing a fine job of keeping sediment from going into it because that's a direct outlet going into the basin. And then perimeter silt fences here in this particular case have been doing a great job of keeping the sediment from getting into the street that would take it to a storm drain inlet. And of course, check dams. And we do have hay bale check dams. I'm not pretending to say that's okay, that one. But check dams that actually do hold sediment back, if they're properly lined, they actually work better. In this particular case, you can see where this riprap check dam has got actually a geotextile fabric on the back side of it and on the front side of it to kind of prevent erosion. And then the energy dissipators and the outlet protection inside of the basin need to be considered. Now, on the left side here, you see where you're going to be breaking up that flow. And that, of course, is breaking up the erosivity of the water volume and the velocity. And on the right side, you just see how we actually have a little course here that Jim Spots does for us. Does a phenomenal job of showing how to actually expedite sediment deposition so you can meet a discharge limit with a skimmer. And so the characteristics of the best sediment basins, we have to understand the pond dimensions. We're not going to get into the details of that. Flow circulation patterns have to be considered. These are things that design pros really have to take seriously when they're putting together the designs for basins for collection pits. Construction components and your discharge management requirements. Required storage size. How many sites have you seen where people have minimized the size of their detention ponds or not put them in at all? Length width ratio, depth, really important things to consider. Here we have a little forebay. It's capturing higher sediment loads. That takes a lot more maintenance. And then as water pours into the rest of the basin, of course, that's going to be taking it to the outlet. Here we have kind of a Baffles situation where they've actually used the soil to actually create a higher residence time. It would help if that soil was certainly blanketed on top there, but they've done a good job of kind of create a higher residence time there before it goes to the outlet. And here we have just kind of an example of what we can do to stabilize the soil, the shape or the outer edges of our basins by using a polymer and grassing to actually stabilize it so it doesn't erode in and of itself. Baffles are really useful if they're installed properly. These are not. Kind of like the weir system with industrial collection pits, as they're vertical, baffles are horizontal and should be placed in a basin so they actually circulate the water and don't just, where the water just hits it and just goes somewhere else with a lot of energy. So to actually create a flow path would actually help that skimmer here in the foreground do a lot better job. And of course, filtration is after we've done a good job of knocking out the sediment load, filtration, and here we have jute mat fencing that actually is going to filter out the remaining clay fine silt particles that before it actually goes to the outlet, so where a skimmer would be. Flocculation is a really important consideration for discharging to a limit that we have established here in Georgia and even in other states. Flock logs are phenomenal. If they're used properly, they have to be maintained like any other BMP. But something else that I wanted to kind of throw out again, Jim Spott's name, that he really showed me a few things here when it comes to skimmer devices. I wanted to close with this, or getting close to it, that you've got to have flow control. You cannot expect a skimmer to really properly discharge real clean water. Of course, much heavier sediment loads would settle automatically, but while water is circulating and while that water during a rain event is rushing into that pond, you're going to get a lot of suspended sediment that you could actually wait to settle out. So if you put a flow control valve on it, then you keep it shut off all the time. Open it up when the rain event stops for about 48 hours, a couple of days, let that sediment settle out. And then, of course, when that happens, then you get cleaner water discharges. And you certainly can expedite that sediment deposition in the basin if you use a polymer. So in different ways of applying that, obviously. So and there's two typical skimmers that we use here, but there's all kinds of other outlet devices that you can use out there. I'm going to kind of move through here because we're getting limited in time here. But layout and configuration is really an important consideration, making sure that your skimmers have a flexible hose that's high, going to allow for it to operate correctly. Making sure that the flow control is completely managed by the permittee and or the inspector working for them, so that they don't just allow that skimmer to just discharge during all intervals of a rain event. And then, of course, removing it at the end of it. Again, just kind of revisiting this, the rigid tube must be long, discharge the pond within 24 to 72 hours is a requirement. And discharge rate is irregular when the height of it is about 6 inches. So what happens with these devices, if you've maintained them, of course, they get super heavy. Sediment is heavy, and you've got to place them to the side of a basin that allows for them to be maintained. In this particular case, you've got to be careful what you're skimming. And when you have a requirement like the National Pollutant Discharge Elimination System has for construction sites of making sure that spills are picked up and cleaned up immediately, sediment that is below a diesel tank in this case was leaked on. When it rained, it carried that sediment with the fixed diesel into the sediment basin, and they're skimming it right directly off into the basin or into the creek. So you got to consider things like that. Discharge during inflow is definitely ineffective. So anyway, as that water then discharges from the pond, then we have a level spreader. It's a great example here. I pulled this off the internet. I just thought, man, it's beautiful, because what they're doing is dissipating that concentrated flow, allowing it to flow over a final filtration before it sheets off into the creek below. That would be a perfect, beautiful little system to put in place. And I know what's probably going through the minds of so many of you, it's the same thing that's gone through my mind, is what's practical here? Who's going to establish practicability anyway? I think, we as professionals, we've got like 300 of them, of us in this course. And if it's not us that take this stuff seriously, then the construction community sure isn't going to. And the construction community's got its challenges big time with managing stormwater and building a site to be profitable. But we need to be working together to come up with solutions that are going to be protecting our watersheds in a way where we can still fish in them when our kids are here and we're gone. We have to understand that that's an important, critical part of the Clean Water Act. So pre-treatment, absolutely critical. So we have to prevent erosion first, manage that sediment second. And if we kind of go through that process, then skimmers can work. we can flocculate that water, it's not full of sediment, they can absolutely work. So in closing, you know, I kind of sped through a lot of this stuff here, but I wanted to mention something about Theodore Roosevelt. He is kind of my hero when it comes to conservation. He was actually a proactive president at a time when people were trying to they weren't trying to destroy our environment, but they weren't wanting to protect it. They were wanting to privatize the Grand Canyon and the Smoky Mountains and things like that. So he, in his, when he was going for president, he had many, many statements that he had. And one particular one is my favorite, says, conservation is a great moral issue, for it involves the patriotic duty of ensuring the safety and continuance of a nation. And if you want to see countries that I've seen when I was overseas and how they did not manage their pollutant loads and their erosion, then they've destroyed their economies. We have got to step it up when it comes to how we manage stormwater on construction sites. And in states like Georgia, where we have so much rain, we have the regulations in place. There's really no excuse for us to be managing the water that we manage the way we do now. I think skimmers are a fantastic device, but if just every BMP out there is needed, we need every design professional to be doing their job. We need every installer to be doing their job properly, and the maintenance is absolutely critical. Not one job is more important than the other. And so I wanted to thank you for so much for listening to me ramble here and share with you my perspective about construction sites management and kind of how the laws manage those types of things. And if I can ever be of any service, if you have any questions now, I'm more than happy to try to answer them. Thank you.
Awesome, Luke. Thank you.
Hey, thanks, Luke. We got a bunch of questions for you. What is your stance on installing skimmers and waterways to collect floatables where floatables?
Okay, so floatables, you know, you're talking about solid waste. It's like anything else. It takes maintenance. There are municipalities that, you know, in certain states that have, you know, passed ordinances that require the capture of solids and floatables, those types of things. But unless you maintain them, unless you're willing to put the money in to hire the crews to maintain them, they're just going to cause more damage. So, you know, it's like construction sites. If you don't maintain your BMPs, then, you know, and it takes money to do that.
Right. All right. Did you cover the installation how-tos?
I covered the resources that you'll use to install the skimmer. I didn't get into the, you know, I mean, a 1-hour class to do that. I kind of had to make my, you know, pick and choose my battles here. And so, yeah.
Can you kind of briefly cover installation?
I'll check it out.
Okay. Are you wanting to talk about the design or installation of them? Like when you took a look at those, I can't really go back here, but when you took a look at those skimmers that were installed through a retrofit, is that what you're talking about?
Yes, sir. Or concrete.
Yeah. Well, you know, installers, you know, when you put in your concrete vault, essentially where your pipe is inserted in the center of it, of course, you've got, you know, your PVC pipe or your flexible hose that's going to have a fitting around it that's going to be able to attach to it. And of course, it's going to have to be sealed. Water is powerful. A lot of times it'll find its way around these connection points. And I think the energy that's created from allowing a skimmer to work during a rain event actually helps kind of decompose the connections that go to a lot of these outlet devices. But, you know, I don't know if that answers your question or not, but.
And just to let everybody know, the manual doesn't specify the size skimmer. It just specifies that you have to dewater from the top. From there, the engineer picks out the appropriate sizing for each site and each pond or drainage basin that they are dewatering from the top on.
And, I think it's worth the conversation. I've talked to the commission and the EPD about this and many other consultants about, what is the actual definition of withdrawing water from the surface from a device? When you have a sediment trap with an outfall or an SD4, it's a rock outlet that's on the perimeter of a site, there's no skimmer attached to that. It's dewatering from a device from the surface, and that meets the requirement. Emergency spillways, when a pond takes in more water than it was designed to handle, and it goes through the emergency spillway to a creek, that's dewatering from a device. So I don't know. I think it's worth a conversation. I don't know. I know our interpretation of using surface water skimmers is one way, and I think they're a great solution many times, but I think there's other solutions too. And of course, the commission accounts for that when you have other challenges. But anyway.
Okay, another question we have is, why would you not want to use a skimmer in post-construction application?
Skimmer and post-construction applications. I guess you have to stay in a pond. If you let the skimmer in, okay. So, well, first of all, you've got an Mpdes permit requirement to remove all temporary devices, and skimmers are those. Okay. So that said, if you have a post-construction ordinance that does allow or require skimmers in a basin, then that would be a consideration. The problem, again, is take a look at any of these post-construction ponds and don't tell me that people don't put their used oil in that stuff and antifreeze and all kinds of crap that goes into these stormwater ponds. So unless you've got a lot of control over what's going into that pond, I don't think a skimmer really is, in my opinion, humble opinion, is the best thing to do.
Okay, next question is, pre-trip treatment required or optional?
Pre-treatment is a requirement. When I say that, I say this, that soils must be stabilized within 14 days, right? And so that's pre-treatment. When we're going to put tackifiers out there to minimize the erosion, that could be used as, mulching or preventing erosion. So it depends on how you look at it. Pre-treatment is absolutely a requirement. The Mpdes permit tries to be sensitive of a construction schedule by allowing them 2 weeks to stabilize it if they're not working in there. I think that's pretty sympathetic to the construction community, where I know some other states, not many, but some other states have a much a sooner requirement, 7 days or 2 days or something like that.
Okay. The next one, have you ever seen a good reason a project did not install an SD3 or skimmer on the initial phase or early in the intermediate phase?
Ever see a good reason why they shouldn't install one in the first phase?
Why they did not install an SD3 and skimmer in the initial phase or early in the intermediate phase?
Not really. I mean, a lot of these questions open up a whole plethora of things going on in my brain. But anyway, I think, when you're taking a look at a design, I think Ben has some good answers for this stuff. But when you take a look at the design, you've got to put in these devices. If they're on the design to put in a surface water skimmer in that first phase, then that needs to be put in. If you think that that's going to be a problem for whatever reason, then talk to the design professional and of course the local listing authority, and those guys are kind of involved as well, and make sure that your reasons are well thought out and accepted. Because one thing I can absolutely say is I think superintendents have a lot of experience with erosion. They're out there when it's raining. They see how these devices work, and so we need to be open as design professionals and other people in the industry to their perspectives on things.
Right. And then the other thing to take into account is the size of the site, and there are a lot of other BMP options that are out there, like SD4s, excavated SD2s, that can be used for approved form of sediment storage. So it's not just that you can use SD3, maybe even a rationale for a retrofit so you don't have to dewater from the top, or justification. So there's a lot of different things out there that can affect that answer. One last question before we have to move on. I'm sorry, but you guys are blowing this one up. Is the Mpdes permit required prior to construction or during construction?
Prior to construction. In other words, the plan the permit is a 5-year permit. It's not just issued for one particular project. It's a general permit that applies to all construction sites that meet those conditions for 5 years. And so the plan, the notice of intent is specific to the project, and the plan is specific to that project. So the plan has to be in place prior to filing the notice of intent. So all the BMPs that are going to be used are got to be on that design. That's what's going to go in for plan review. And of course, there are challenges that happen as projects get put on hold for whatever reason, economic issues or whatever. You might have a project that's been on hold for 3 years, and now all of a sudden, the plans were reviewed and authorized, but now they're going to start installing them. There's all kinds of other things that can influence that answer, but anyway.
There was one other, we still got 2 more minutes. Somebody asked, there are some municipalities that report they get more complaints from neighbors when skimmers are used versus no complaints when retrofits are used. Can you provide any information or background basically on that?
That's a good question, but I mean, there's all kinds of, I tell you what, the human element involved in this program is massive. I mean, who knows what conditions have caused a neighbor to complain downstream. If skimmers are dewatering a lot of clay, then I think they need to consider flow control and flocculating their water before they discharge. There's things you can do. I think flocculation using anionic polyacrylamide is one of these things that's an underutilized BMP. It's an accepted BMP in Georgia. The negatively charged, not the positively charged, the negatively charged ions, because that does not create aquatic fish kills and stuff like that. So
Right.
Yeah.
Yeah. And just some of the things that I see when you go out there, skimmers, they need to be installed per the design. So if you're specified a certain size skimmer, you need to make sure that you put that out there. You're buying the right one with the right head and orifice size, as well as the right length of pipe. There's been many a times I've gone out to a construction site, it rained a whole bunch, and the next thing I see is the skimmer upside down. It probably got flipped over and the pipe's too short, something like that. The other thing that I've seen happen is shut off control valves. While they are a good thing, they do require a person to go out there, turn them on and turn them off. So if you've turned it off, don't forget to turn it back on and let your pond, overflow through the emergency spillway, potentially blowing it out if it's not big enough. So make sure you're monitoring all those things. So there's a lot of different things that are out there that can be used. And thanks everybody for your great questions. And thank you, Luke, for all your time and doing a great
Thanks so much
presentation.
for having
We
me.
definitely appreciate having you today. And thanks so much.
Thank you so much. You guys have a good one.